we have many models which exhibit spatial characteristics, spatial embedding, but where agents are not mobile. And that is, they don't move around. An example of that would be the game of life. Cells come into existence in a cell, die in a cell. They don't move. Agent mobility involves movement. And in fact, the Schelling segregation model does involve movement, for example. Within 2D spatial embedding, we can either have, you may recall, a continuous embedding or discrete embedding. For continuous embedding, so for each of these, mobility patterns are different. For 2D spatial embedding, agents move in a direction and with some speed. For discrete cells, only one agent can be in a given cell at a time, and they move discontinuously or continuously from cell to cell. They can move from cell to neighboring cells, for example, in a discontinuous, so in a sort of moving between cells in a sort of sudden fashion. Okay, let's talk about continuous space. These are the relevant methods to use. We can ask an agent to move to a certain place, or set the velocity of an agent, or set the XY position, or jump to a certain location. Set XY is to set the initial location. Jump to moves the agent to a location. And set rotation rotates an agent around. And then you can ask information about the agent, like get your X location, get Y, whether you're moving, what's your target if you are moving, so where are you going, and what's your rotation. Where have we seen any of these before? Can anyone tell me? We saw them before. Where was it? We saw 2 of them before. Yeah, get X. Yeah, exactly. When they were going out, it was for linking people together. That's where we saw. Yeah. Okay. Oh wow. Okay. I'd like you to create a new project called Movement Towards Mouse. Okay. Don't worry, this will be about computer. Sorry? Okay. Yeah. Well, there'll be no free mice here. All it is silicon mice from now on. Okay, so this is called Movement Towards Mouse, Sydney. Okay. Do you have mice here in Australia? Huh. I wonder. Well, I'm interested in finding their paleontology of mice here. Okay. So movement towards mice Sydney. We have created. I'd like to now create a new active object and call it person, and make it an agent. Remember how to make a person an agent? People? Remember how to make it an agent? I'm going to add a new agent class by right-clicking on the project as a whole. And how do we make a person an agent? We agent on the person's general properties. And it's very important to remember to do so. They won't be able to be connected in networks, for example, unless they're an agent. Okay. They could still have an appearance and so on. They could still be embedded, but there are certain things they can't do unless they're an agent. Okay, so general here, and we'll make sure they're an agent. Okay, agent. Okay. Okay, now I'd like you to drag an oval to the origin. This may be familiar with by design, because we're going through some basics here, and people in previous encounters have expressed the desire to have more sort of rehearsals of tasks, of basic tasks. Okay. So we're going to drag an oval to the origin, okay, and at one point, folks, it's actually important that we're next going to add this person to create a population of people. How do we do that? Who can tell me? So I want to create a population of people. Where does the population live? Maine. So let's go up to Maine. And then how do we create a population of people? Sorry? Yeah, we drag person over there, and that creates that population of people, right? Population. Now you'll notice that this presentation appeared there. One important thing to realize is if you don't create the presentation before you drag them in, then you're going to have to use this create presentation button here. So once you modify the present, or once you introduce the presentation for a person, if you created the population before you define the presentation for person, so you go back and you add a presentation for person, then you have to come back, select the population, do create presentation, and then that will create the presentation for them. It's a little bit confusing. It used to be even harder, but now you have to do this button. So just remember that if you have trouble making your people appear. If you didn't add that presentation beforehand, you want to add it. Okay. How do we make this a population? How do we make it not just one person, but a set of people? Anyone? Sorry? Replicate, exactly. So this replicated, and we're going to do it with population for now, okay? So you may ask why, but we're replicating it, but it's going to go up. Okay, population of 1. Okay, I'd like you to run this. If you do so, you should see something like this. Why aren't we seeing this laid out at a random place? Why isn't there's no environment to set their location, okay? Okay, now I'd like you in main, so that's all we're gonna do right now. Now I'd like you in main to set a rectangle, okay? To drag it and put it at the origin, one corner of it, like that. See that? So I just drag the rectangle here. This is main I'm looking at. I'd like you to drag it to there so that its upper left corner is at the origin. And then I'd like you to enlarge so it's down to the lower right. Why am I doing a rectangle here? Because I want something to sense when I'm clicking on it, like where I'm clicking. And so I'm putting something in place that will sense sort of where I'm clicking. And then I'd like you to right click on the rectangle and say do order send to back, okay? Has anyone done that in any other software package? Do send to back. Where do you see that? In Office, right? Yeah. Oh, okay. Is that right? PowerSim also has that? Yeah. So, okay, so you right click on the order and you do send to back. Okay. Now it puts it behind this sort of ball. Okay. So now I want you to go set something so when we click on this rectangle, the person moves to there. If we wanted the rectangle to do something when we click on it, where would we put that? The action for what? For a rectangle, and where would that live? Where would we find that in the AnyLogic model? The action for rectangle. In dynamic. And the dynamic associated with the rectangle. So we're going to go to the dynamic associated with rectangle and go to the on-click handler. Okay, so that's the action that takes place when someone clicks on it. And this is the code that I'd like you to put there. Okay, this code moves the first person in the population, the person at index 0, just moves it towards where you clicked. Okay, this move to sets them in motion towards that place, okay? So population.get0.move to.click. And where did this click X, click Y come from? Where did that come from? Where did I conjure that out of? From whence did that come? Okay, we are passing them as the parameters of move to, but how does it know what click X is? Why doesn't it say, I don't know what it is? How does it know what it is? Exactly. It's provided by the context. So AnyLogic provides it as, and how that is what I'm getting at, because you got to keep your eye out for this. We've actually seen a similar thing before. Times. How do we know that what's the cue that alerts us to the fact that it provides us with that? People? How do we know? It's a light bulb. We've seen that for the case of message, where it provided us with MSG reference to message and sender reference to the sending person. We saw it with respect to item just earlier when we were doing the statistics. Remember that? So here in the onClick event, if we start typing this rect thing and it says use click X, click Y, shape relative coordinates of click. Okay? So we want to do population.move to get 0. So that's where it knows click X and click Y for. Does that make sense? People? So it's providing it. And again, if I do Control J, if you're too squeamish or nice or this, but if you don't feel too squeamish, let's go see where it is, and it's suspenseful here. It's taking a long time. I did Control J, and it is intending to call this up, but there we go. So this is where it is. It's in a thing called onShapeClick, which is so-called handler, and it says, okay, if we're in the rectangle, we're going to move to click X, click Y, and those are just provided around this. You folks don't have to look at this, but occasionally, if you want to understand kind of what's going on beneath the covers, it doesn't hurt. Okay, so let's run this thing. So first I'm going to try. Oh, I already built it. So are you folks running? What's happening when you click on the rectangle? Does anything happen? Sorry? And here, I'll come take a look. What error is it saying? Oh, missing semicolon? Okay. Does anyone else see something different? An error? People need help? Help? I should have kept that up there. So this is it? It was get 0. Yeah. Well, sorry. Where is it? There it is. So really, this should be this. I think it should be this dot population dot get 0 dot move to. I don't think we're in any sort of odd thing for the for the thing. So it's this dot population dot get 0. But you could just put a population dot get 0. What does that mean? So I'm asking the population, what do you think this get 0 means? Anyone? It gets the first agent in the population. They're located at location 0. And then it does move to, it tells that agent to move to this location. Did that syntax error get fixed? Okay, so are you seeing some things going on? What are you seeing going on? Is this what you're seeing? Okay. Okay. So here we're seeing some movement on the part of an agent. Let's go set it speed. Drag a slider from the controls area. The time we've ever done something like this. Okay. So from controls down here, I'd like you to drag in a slider button. Okay. See that? And this slider will let us select a variety of possible values, okay? I'd like to name it velocity slider, okay? Velocity slider. In the general area, call it velocity slider. And I'd like you to, minimum value is 0, its maximum value is 100, default value of 0, that's fine. Okay. So this is velocity slider, so I'm gonna go name it that. Okay, velocity slider, and it goes from 0 to 100, and now we're going to set the item's velocity accordingly. So I'd like you to actually, after you've got that velocity slider there and have named it velocity slider, I'd like you to actually go modify that code you had. This has to fit. Modify the code that's in place for the for the click handler, so that it sets the velocity according to the velocity slider. Okay, and this is the code here that will be here in just a second. Okay, yeah. There we go. Okay, so it's going to be all the same up to just after the get 0 dot, and then it should be set velocity, and it'll be velocity slider dot get value. Okay. So does anyone want to tell me what's your best guess as to what this does? Velocity slider dot get value. What do you think this does? Sorry? It gets the selected value of the velocity slider as a number between 0 and 100 in this case, based on the settings, and then it passes that number. That's some number, and it's calling set velocity with that. So it's going to set the velocity of the ball to the appropriate number. Does that make sense? Does that make sense to people? Okay, so we're going to have to set the velocity of the ball accordingly. So I'm just going to copy that to mine here, and I'll put it up there again. So it's same thing up to get 0, then dot set velocity, and then inside of that it's velocity slider dot get value, begin paren, end paren, and end that. Okay. Okay. So I've got to go to the click handler for the rectangle, and I've got to go to dynamic, find that in the dynamic properties. Okay. And we've got to insert that code there. Okay, does anyone want me to put that code up again? Okay, you got it. Okay, so code is as follows. Dot set velocity with a capital V, velocity slider dot get value, and that get value, it's a begin paren, end paren, because it's a call to a method to get the value, and then that value that's returned is passed to this method called set velocity, and there's a semicolon at the end. Would anyone like me to keep it up longer? Longer? Can we go forward? Do you want to run the model? Have some of you already? Okay. Good. Okay, so let's, for those who haven't, let's go run this model. And now we can move this velocity slider, and we could have the ball go faster. We could have the ball go at its fastest speed yet. And we could have the ball go very slow indeed, based on where we're clicking. So this agent is moving. It's moving around in space. And in fact, if we go down to the agent level, we'll see that particular agent moving around. There's only one agent, so there's only one to show. So here we've mobility. It's mobility directed by the user interface, and it showed us how to use a slider as well. Okay, I'd like you to go to person, agent properties, under person, and you can actually add a bit of code to indicate when the agent has arrived at its destination. Okay, so there's on arrival handler for the agent. So if you double click on person and you go into the properties and you go to agent for that, there'll be an on arrival, and I'd like you to put in just a bit of code that has trace ln, and it prints out a message saying I have arrived. Okay, on arrival here. So we could just put in a trace ln, all in lowercase, I have arrived. Okay, so this is just a little bit of code, and I'll go if I see if I can put it in my thing here. There we go. I have arrived. That's all I put in there. So now when the agent arrives at its destination, it will actually put a bit of a message out just saying that this has arrived. Okay. So we're running this. There we go. And I'll just click near it, and when it arrives, there it says it's arrived at its destination. So okay, this says to use wandering elephants. I think I'm not going to do that. Instead, what I'm going to do is to there's a bunch of information here about how a model which involves a lot of mobility, how that's put together. But I think what we're going to do in our remaining time here is just have a bit of extra action with respect to this. So first of all, I'd like to go back to main and go to the population and change it to more than one agent. Okay, I'd like to change it to 10 agents. Okay, so the population size should be changed to have a replication of 10. Okay. Okay. Okay, so 10 replications of objects. And next, what I would like to do is to drag in an environment. We do that through general. We're going to drag in an environment to main. Okay. And we can just leave the default properties of the environment. There's nothing too substantial, but what we need to do is to set the population to use the environment as its environment. Okay. So remember, populations, to get spatial context and network context, they need to depend on an environment. So we're going to have environment here as our environment. So if I run this, what should I see? So what should I see now? How should it be different from what I'm doing? Can anyone say? How should what I see be different from what we've seen? Okay, now we see this. Now if we click, oh, we're going to have to move the slider. Now this must be person 0 there. See that? But the other persons are located at their location. Okay, so now we have them scattered around. Let's just put in a bit of trivial mobility. Okay, so let's go to person, and we're going to insert a state chart. Okay, So let's go insert a state chart entry point. That's going to get us into this state chart. Yes. Oh, I see. That's a good question. I'm not going to worry about it much because I'm not going to be doing much interactive stuff now. This is just a final little bit to finish up. So you could. That would be a good thing to do, but I want to push forward to just finish up in the next few minutes. Okay. So I just dragged in state chart, and we can call it mobility state chart. Okay. So I dragged in an entry, and this is going to be a particularly simple state chart. I'm just going to have one state, which is going to be in motion, okay? An in motion state. And then I'm going to have a transition from that state to act itself. I'm going to double click on this transition and have it brought back to itself. And this transition I want to be triggered in the context when the agent arrives. Okay. So when the agent has arrived, I want it to go off. So how would I have this transition go when the agents arrive? Can anyone say? If I want this transition to fire when the agent arrives at its position, how would I do that? Okay, you could do it with condition, but there's actually a choice there. Agent arrival. Okay? So when they arrive, it'll actually be triggered. You can set it. That's one of the options. Okay. So when they arrive, we could set it there. And now we're going to go to this state, ladies and gentlemen, and we're going to move them. We're going to perturb them their target location. So we're going to move them to a nearby location. Okay, centered at the current point. Okay, so when they enter this state, whether from coming into it the first time or through this other transition out and back in, we're going to move this person. What do we do to move need to move this agent in a certain random direction, or to move it in a certain towards a certain point? What's the method we use? Sorry? Move to. So we do this dot move to. I'm moving myself to a location. And what if I wanted to have it move to a location just around me? Let's suppose I wanted to move it to a location that's displaced for me by a draw from a normal distribution with a certain fixed standard deviation but a mean of 0. So it's some location around me in X and Y that's normally distributed. The perturbation is normally distributed. So how would I do that? Can anyone tell me? So what do I need to move it to? I want to have a certain offset from my current position by an amount that's drawn from a normal distribution. Good. For X, that, and then for Y, the same sort of thing. Actually, we could do it in two ways. We could have it. We could express it this dot get X plus a draw from a normal distribution with mean 0 and standard deviation, 50 or something like that. That would be one option. And then what would I put for Y? How would it be different for Y? If I wanted the same distribution, just offset from Y, what would I put for the Y here? This is the X. This is where I'm telling it to move to for X. How about for Y? Yeah, just get Y. Exactly. So that would be one option to put it. Another way, can anyone tell me another way to do this? Using almost the same thing, but a little bit simpler expression? Well, another thing I could do is I could have a normal with mean that and standard deviation 50, right? I could do it either way. Frankly, conceptually, I kind of like implying there's the current position plus some perturbation. Does that make sense to people? Okay, and ladies and gentlemen, if we wanted these people to each have their speed set to some higher velocity, say velocity 100, where would I do that? If I wanted the agent to have a starting velocity of 100, where would I do that? When the agent comes into being, I want it to have a velocity of 100. How would I communicate that? Anyone? Well, just as there's a startup for main, there's a startup for person. So one possibility would be to do it there. I would argue that maybe a more transparent possibility is when they come into this state chart in the first place. The very entrance to the state chart, we do it, have an action there. Okay, so folks, how do I set a person's velocity? Tell me what to type here. I stand ready. Sorry? This dot set velocity. Spoken like a Java programmer. That's great. That's great. This dot set velocity, and you give it a value of 100, right? Right? That's how we talk to each other a lot of the time. So that's exactly what we say. So this dot set velocity 100. This is coming into the state chart. So when they first come in, it's set to that. Alternatively, I could put it in the startup code for the person, but this makes it more transparent, I think. Okay, folks, should we run this model? And then this will be the last thing we do here today. The last thing you do with me today. Okay, so let's run the model. Who needs help? Who needs? I'll come and help there. I'm going to put this on the screen just so people can. I'm coming up there. What error message is it giving you? Okay. Okay. Oh. Okay. 100 red balloons. Okay. It should be jet X capital, and then the inference, so you make capital Y, and then the inference and inference, because that's a method call. This is the inference. Yeah. And then you need the same thing for X. Yeah. Oh, the transition is triggered by on or agent or object, and then there's that's all it needs. Okay. 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 So we saw something curious. It wasn't what I fully intended here. Okay, so say this again. What you're saying sounds plausible. So what I was setting it to be, they're moving to the current position plus a draw from the normal distribution with oh gosh, oh my gosh, oh, that makes me feel really uncomfortable. Normally when in most packages like R, the mu comes before sigma in a normal distribution. So you have the mean before, and here it's the reverse. Well, Well, you learn something every day. I don't. I'm not comfortable with that. But okay. So we had 0 standard deviation. And we had a 50. So they were just being propelled in sort of a defined direction, defined by a diagonal one, into oblivion. Okay, so now we've run it, and what should we see this time? What do you see? That's called a Brownian motion, random walk. These agents, when they arrive, they start in a new direction. Every time they arrive, they come back into that state, and then they head off in a new direction. So here are agents, and if we zoom out, we can see they're kind of diffusing throughout this space, getting further and further away. So do people see that? So the correction that was made is that I was assuming that the draw from the normal distribution, you give the first the mean and then the standard deviation. It turns out you give the reverse, so it should be 50, 0 instead of. So here, folks, I should put this up on the screen. There we go. It should be this guy here. Does anyone need help? The silence is uncomfortable. Does anyone need help? Do people see the balloons moving around? Okay. So what's going on? We're going to be finishing here. So with this, what's going on? They come into the state chart, and it sets their velocity to 100, so they move reasonably fast. They come into the state then, and it does this thing. What does this thing do? Who could tell me what it does? Descriptively, what does this do? Yeah, it moves them in a certain distance in the x direction as drawn from a normal distribution with mean 0. So on average, it doesn't move them at all in x, but on average, but it moves them some in x or y direction according to a draw from a normal distribution with standard deviation 50, and sometimes it's negative, sometimes it's positive, and similar for y, right? And so they're set in that direction, and then when they arrive, they go. What happens when they arrive? Can anyone tell me? When they arrive at that position that they headed to, what happens then? Sorry? And why is that? Yeah. Okay. And what is triggered when they arrive? The transition. This transition. So they leave that state and come back into that state, and that's why that code that's in entry action gets fired again. So they're sitting in the state in motion until they arrive, and then this transition gets fired. They come back into this state, so this entry action gets going again, and it fires again while moving. Does that make sense? So, ladies and gentlemen, this Brownian motion can be expressed as sort of the series of disturbances, sort of picking a random display in the x and y location, and the things are moving around in space. Now, I have an exercise which builds on this, some more iterations. Turns out AnyLogic provides some powerful means for asking who's the nearest neighbor, what other agent is closest to us, and essentially you can detect collisions, you can detect points of contact, you could have transmission of infection when two hit each other, for example, etc. But this is a simple example of mobility. And you can see it's actually reasonably sophisticated. I mean, these things can really move around. It can control all of them. And ladies and gentlemen, it's with quite an economy of description. I mean, I I know that the Java code is a little bit new to you. A question like this may look daunting, but from my standpoint, it's a little bit impressive. You can have a whole field of 10 or 100 or 1,000 things bouncing off each other with just that little code, that little mechanism. It's not to be assumed. That's my last little exercise we'll do for today. In the sort of the coda, the denouement, the grand finale, I will now set this to be a population of 100, and we will see them wiggling around as I exit the stage. Okay. Okay. So that's it. Unfortunately, my computer is not making it any faster. Okay. Okay. So. Oh. Come on. Okay. Okay, Andre, so are you ready to go?
Yeah.
Okay, great. Okay, so, oh gosh. Well, I'll leave that exercise to you for the 100, but it's a sight to behold. Okay, very good. So that's all we'll be covering with ability. I'm glad to answer questions, of course, about it.